I have been working as an Android developer at Freshworks for 3 years, and I work on their Freshdesk app, Android app. And so like we recently refactored our app, and initially we just wrote some kind of MVC, and I've completely forgotten now after like rewriting. And now we have like changed our app, which is now using MVVM. And so we have like 5 products, and out of which we have tried out MVP. One product is running MVP architecture, we are running MVVM architecture, and I think new products will try out MVI, which is I think completely new. So why we chose this? Because initially when we just wrote MVC, and then there were a lot of issues like handling configuration changes and all of that. We just tried to keep our app in the portrait mode. Like that was the safest we could figure out, or we made sure that configuration config which we put inside our manifest to make sure that nothing happens when the orientation is changed to something, which is one of the really bad ways to that's like you're not allowing the activity to just die completely, and then there's a hard way to stop your activity from going through a death process. So that's not recommended. That should be the last option. So we just wanted to be safe there. We wanted to have the app. We wanted to support the app in portrait and horizontal mode. And so we luckily that's why like MVVM was in full hype, and we got to know about live data and observables and RxJava and all that. So we tried to take advantage of all of it. And currently our app in production is made using MVVM, Rx, Dagger. I mean, it's completely different. But yeah, so the idea is using a publisher and a subscriber method, which has helped us in a lot of ways. So I just want to share the learnings which I've had in last 1 year. So we'll just see what has happened. Yeah. So saying that I work with a team has worked with MVP and I work with MVVM, I can just let you know the differences. So what happens is there are like 3 entities: model, view, and presenter. And model, view model, and model, view model, and view. So if you see, only the middle guy is changing, which is the presenter, which is here, and in this case it's view model. Apart from that, everything else is common. So this basically handles your activity fragments or any other views. Model is basically from where the data comes and all that. So I think we can just leave these two, and right now we can just concentrate on presenter and view model. So what is the difference? What happens in MVP is the presenter is sort of coupled to the view, because it keeps the reference of the view. So it's still more like a very callback oriented model, where you have a view, and every time like say a API call finishes, you call view dot this method. So basically a presenter is very tightly attached to a view, and you can't really like reuse presenter just like that. Whereas in case of view model, it is a lot of observer pattern, where what happens is view model. So what happens is the view model, right? It has no information about which view it is attached to or what, because all it does is it just gets some event and it just keeps sending the event, irrespective of who is subscribed to it. So basically the views are just gonna subscribe for the events, and so what happens is there's no connection. So what happens now, the unit testing is like super easy, because you don't really have to mock the views and all. You just if you just want to test view model, it can be like independently tested. So one rule of thumb is that you should not have r dot anything inside your view models. So like I said, this completely pure Java code. You have to make sure, like if you want to have like strings, or just pass ID some way, and never have a context or anything dot r, because r is like where Android gets selected. So we have to ensure that we write a view model in a way that tomorrow if say iOS code wants to use it, like I mean not like just like that, but the logic has to be like, they can just, even if they want, they can just copy the logic and they can keep listening for the events and it should work. So that's the main thing. So yeah, the major difference is MVP is still a very callback oriented because it has view model, it has view in it and it keeps calling view dot something. So like API fetch happened and it calls view dot fetch completed. But in view model case, if API fetch happens, it says that API is completed. Whoever is listening, just do something. So that's the difference. Yeah. So like I'll just give you the thing that now since I've worked majorly on MVVM, we'll continue with MVVM and majorly like live data. Okay, observer I believe can come go ahead with MVV as well, but live data since it's more like we is gonna observe it, so I'll use it with MVVM. So what happens when like you are running and say an activity started and then you start an API call and you just rotate the screen. So what happens if API call say like generally I think although it has become little old where developers still use async tasks and all, but then async task has its own disadvantages. Like you have to make sure that the view, so if you're giving a reference of the view and then you rotate the screen, so a new view has got created. But what happens is the API call once finishes, it tries to access the previous view. So it's like it doesn't find and the app immediately crashes. So you actually have to put a like null check, the view is not null, then do something and reuse. So that's like an extra thing which we can completely avoid when we use view models. So what happens? So this is the life cycle of the activity and this is the life cycle of the view model. So basically what happens is view model survives longer than the activity. And this is the one reason why you should not have activity references and view model, because view model is gonna stay longer. So if you rotate the screen and my activity wants to die, it cannot because view model is holding a reference, which is a leak. How this thing works is, what happens is when you rotate, only the view dies, and it is no way dependent on any view model or anything. Like no one has kept a reference of it, so it can completely get destroyed, and then it starts with on create, on start, on resume, everything happens. There is no way it is stopping in mid. But the view model does not die. Like on rotation, the view model is just there intact. And how it does is how it handles internally. If you see the code, it basically keeps a map. So what happens is it sees, okay, if this view model is already present, then just give away the view model, else create view model and give. So that's the thing. Yeah. So basic thing, on create, on start, on review. And when the activity is rotated, it goes on work, on stop, on destroy. On destroy happens, and it is safe because no one's keeping a reference of it. Because if only it was a presenter here, then the chance of having a leak, because presenter holds the reference, and that is an issue. So now that it has completely destroyed, it will again start calling the complementary methods like say on create, on start, on review. So it has like died completely and it has been recreated. So it's a complete new instance of that activity. And yeah, and talk about on cleared. Android is pretty smart. It knows that when to call on cleared and when not to call. So if you're just rotating the view model, on cleared is not called. Like, but when you actually manually kill the activity, that's when on subscription gets cleared and on cleared happens. Yeah. So the first thing is the two ways where a view can listen for events. So the idea is in MVVM, the view model is there. It's gonna receive some events and it's gonna just push it to whoever listens. Like say like 10 fragments have subscribed. So there's an advantage. Like it's very loosely coupled now. So one view model can be heard by a lot of views because there's no reference. So it's all possible. So what happens is so now what are the ways in which a view can listen to a view model? Like how can view emit events? So basically there are two ways. One is observable, one is live data. That's what we'll talk about, but I'll talk about what the differences are there between two. So when given a choice, we get a lot of doubts when to use what. And so basically like observables, like it comes as a part of the RX library, where you can just do. I mean, I'll just go through the code one. So like when you give a search, there's like a lot of things like live data versus RX, live data versus flowable. I mean, these are basically kind of observables only, and yeah, I think we'll just go ahead. So this is the questions like this has given me motivation to talk on this. So I'll go ahead with an example. So I have just tried to keep it simple. Let's try. Okay. So I'll try fetching. So the code will be like, it will be fetching something over the network, and then what happens is I'll show a loading, and once the API call is completed, it will show a dialog saying that update is completed. Okay. So I will just going by the example. It's going to be something like this. Yeah, and that's it. So I think this is something we'll try to create, and this is what I've gone by the code. You will see the code. This is how it is. This is a view model, which is so here I have just okay. Yeah, okay. So what happens is like there are so how I have written is there are two observables, basically behavior subjects. What behavior subjects are? They are basically observables which can act as observables and subscribers. Like there is a special kind of observables which can emit data and which can also listen for data. So I have created like two observables. One is like, is API successful, and one is like behavior subject saying that is show progress or not. What happens is when I start my API call, I can just say like, okay, show the progress, and I can also say that is API call and I can after the API is successful, I can say that API is successful or not using the live data. So I do this by calling onNext. What onNext does is, when it is called on a subject, it basically emits that event, and whoever is listening for it will receive it. So yeah, so here it is. So let's just consider like API fetch successful and showing the dialog. So once I started and on subscribe, so basically fetch users will basically fetch make an API call, and it will happen on a completely different thread, because observables are handling it very much on their own. That completely depends on subscribe on. So in subscribe on, I specify on which thread I want this execution to happen, and I'm giving it IO. So the execution of fetching user will happen on a separate thread. And I also tell that, listen, you do something on thread, and then I'll wait on main thread, and you give me the result back on this thread. So fetch user happens, and after it's completed, it gives me on the main thread, and then I just publish it saying that API call is completed. And what happens? And this is my view. This is my activity, which is basically waiting. Like here it is subscribed. It is subscribed for that particular event. So whenever that event is successful, I try to show dialog, else. Yeah, that's it. And one more important thing is, I am destroying it here. I am destroying the subscriptions to the to the observables here. Okay, I'll tell you what is the significance of that. And I'm doing it in on destroy. Yeah, so basically this is it. So first I had the screen, and I started the API call. And while that was going, I rotated my screen. So what happens is, since it's a view model, so my activity completely died. And like a brand, so in destroy, I cleared the subscriptions. So now that new subscriptions happened in on create, and then events got delivered to the new subscription. So that's an advantage here. One thing, be it live data or observables, they give whatever they have to the latest subscriptions. So that's why on rotation nothing crashed. So this example I have done using behavior subject, which is an observable. Okay. But okay, as of now it's fine. So if you remember, I cleared the subscription only in on destroy. Now let's see what happens in this scenario. Okay, hold on. I think this is fine. Absolutely, because I cleared subscription and resubscription happened. So yeah, so let me just tell you that on all of this happened, and then I rotated. On destroy gets called, I cleared the subscription, and then recreation happened. So new subscriptions are made to these observables, to these subjects, and then it continues. So like whatever data came in inside that subject got delivered to the new subscription, and hence I saw the dialog. So this is fine. But just see this case. So I just pressed home button. So there's a crash. Can someone tell why it could be? So I mean, just think around what happens when you rotate versus what happened when you just press home button. Can someone tell me?
Activity gets destroyed.
Okay. No. So yeah. Okay. I mean, I think there's a difference when it gets destroyed and when you just press home button.
Suspended.
Sorry? Yeah, it is suspended, but up to what state? Yeah. On destroy won't get called. So yeah, this is the difference. So when I rotate the screen, pause, stop, destroy gets called. But when I just press home button, destroy does not get called, right? So what could be the reason for this crash?
On destroy,
Subscribe. Yeah, well that's okay, because even when I rotate, it's trying to connect to the main thread, right? So
But still the application is running, right?
yeah.
So the main thread is in that.
Okay.
Observable is trying to state dialog with activity stop.
Yeah, and what is the exception called? I mean, Okay.
No exception.
Sorry.
No exception.
No. No. Okay. I'll just reveal it. This is called. Yeah, that's absolutely right. So it's trying to put in dialogue on something which is dead. So it's not really. So what happened is, in this case only on stop was called, on destroy was not called. So what happened? The previous subscriptions remained. So I didn't clear those subscriptions. So now when this API call, like I reopened it, and also basically now the subject got 2 subscriptions, and for the previous subscription it's trying to draw the dialog. So I'll tell you. Can anyone, if anyone wants, can they tell what is the reason for this on saved instance state exception?
When activity goes out of some period, basically say all the on state function to save the current state of the activity, so that when you reopen, it will pick up from the state and show the activity.
Yeah. Okay. So from API 28 and above, immediately after on stop is called, there's on saved instance called, but in the previous API it was between pause and stop. Okay, although they have given us a little bit of time, but it is still causing a crash today. So what happens is, in this state, consider it like it is gonna store the information, like what all the activity has, like say it has a recycler view, it has a text view, all that it is available. Now I have pressed home button, so it knows that it has only recycler view and text view. Okay, now the subscription has not died. So the view model thinks that okay, I can publish, and the old subscriptions keeps getting the event. The old subscription, I say that draw the dialog. So drawing the dialog is a fragment transaction. So it's trying to draw on something which was already like sealed, that only 2 things are available, probably a recycler view and a text view. So I'm trying to draw it on something. So that's when my Android like blows up, and it tells me that I cannot do this because there's something like already fixed, and I can't create a dialog on this screen at this moment. So this is why it happens, and it just not applies just to the activity of the fragment and to the view. So you have to be very careful. So what can be the solutions for it? Either you allow commit allowing state loss. It's not really a super good way to do. because like you might see dialog, might not see dialog again, and then you wait until the activity, or you wait until the activity comes in a safe state. What do you mean by safe state? So the safest way will be to register for events in on start and to unregister it in on stop. Okay, because on stop is gonna be definitely called be it I press home button or I rotate. So my previous subscription will cancel and new subscription will come. That will never get an issue. Then on start and on stop gets called a lot of times. So like if I bring an activity on something on say activity A is there and I bring a B on it without destroying A. So then what happens? Even in that case, A is called and all. And if I try to show dialog on that, it might not be a really right way. So this is where I pitch live data. So live data very similar to observables, just lifecycle aware. So it was announced in 2017, Google I/O 2017, and yes, it is a sort of observable which is very lifecycle aware. I'll tell you how. I'll go code wise. And it was a Jetpack component. So like a room database automatically is available to give us live data, like whatever data it has, even say like some record got modified. So that modified record can be given as a part of live data. So it's like supported with a lot of Jetpack components. Yeah, so let's change our code. Instead of using a subject which is not observable, let's try using live data. So this is the change I made, and this is how I make this change. Like instead of calling on next for an observable, I call set value for a live data. So it's the same API call, but I'm not using observable, I'm using a live data. And this is my view change. So yeah, so previously the view was subscribed for an observable, but now it is observing a live data. So that's the only difference. But there's a super big difference, and that is this. So this is basically the lifecycle owner. So this is where you inform that until this is alive, keep sending me emails. This is the difference, and which is the major. So what happens is now when your activity is like stopped or something, it is quite aware that I don't have to give event because this has gone to on stop. So only when it is visible, this thing is gonna give me events. So that's how we make it lifecycle aware. Okay. Plus, yeah, I still have that. I don't have it here. Just know it. It's live data. So now after writing with live data, I press stop and there's no crash. And when I just open, I get the latest data. The idea is same. Both observable and live data give whatever they have to their latest subscription. So, but live data does not give, because it's very aware that okay, at this moment the activity is not visible. What's the point of me setting the event? And that I myself tell by specifying on this. So this is it. Yeah. So the comparison of these two. Both of them caches one item only. Although, like if you go ahead, well, subjects, this is very specific to behavior subject, because if you go by replay subject or something, so what happens is, say like I have some subject has passed me on next 1, 2, 3, 4, and then after all these 4, a new subscription has happened. So again, the new subscription will get all 1, 2, 3, 4. So this is very specific to behavior subjects. All of them caches one item at a time. Like once it's gone and a new item comes, the new subscription gets that latest item. Yeah. So live data, one disadvantage, it happens. All the emissions can happen on the main thread. Why? Because I have provided this, and this is what is the life cycle. Life cycle is where main thread, and it cannot. So that's why it cannot post something on a background thread. There's no point. Right? This can be observed from any thread. I'll show you by example. Live data, like I just showed you, it is when it only emits when the activity or the fragment of the view is in safe state. Okay, it knows that when it has gone in on stop, there's no point of publishing. But when it resumes, it immediately gives the old data back. So it's nothing to lose. Okay, but yeah, there's so much advantage with observables. There's like a lot of operators. I mean, I don't know how many of you tried RX. Okay. Well, the RX basically gives out observables, and what happens is you can just transform a lot of. Even there are a lot of operators on which you can work on. So what happens is, say I get probably an API user which gives me a lot of information. Say it gives me name, surname, DOB, but to display on UI, I probably need just the name. So how do I modify? How do I transform this API user to a UI user? Like UI user, consider it as a state which is visible on the screen. So how I do it? There are a lot of operators. I apply flat map, and all that. So you have worked with RX.
You're still not used to that.
One super good advantage of subjects is that it has an error channel. So in case an error happens, especially in observables case, an API error happens. So when you subscribe, you get to also subscribe for errors, not just the result. So in the error, you can handle that. Yeah. So every good things comes with some drawbacks, and at this moment, live data just supports very limited set of operators. Flat map, distinct interchange. These all comes very handy in RX, which means observables. But when it comes to live data, we have very limited operators. Plus, these operators all work on main thread. So which is not a very good thing to happen, because we want everything to happen on a different thread, background or computation, whatever thread it is. Only the rendering should happen on main thread. That way you won't see a glitch or anything, because your main thread is just doing the rendering. Everything else is it's main thread's task is to just render stuff. So yeah, so the problem today is live data. Like even if you try to transform a live data, say like I get API user as a live data, and I transform it to like UI user. So I write a transform something. What happens is it happens on the main thread, and if it is like a big process, then you can see like slightly glitch. Like if you have to display in list, and there's like a lot of data coming, and you have to convert a lot of data into UI user, this is a glitch. So that's something. Although you have to separately handle threads. Like you have to specify like, okay, let's use this thread for transformation, let's use this thread for just rendering. So there are ways with which you can make sure that transformation can be done on a background thread. But I think that it's like reinventing the wheel, because observables are just there with everything intact. Like so they make sure that they have everything ready, how to pull things on a background thread and how to just give it to render on a main thread. Yeah. So why? So I told you there's a view model and there's a model, right? So view model is giving events to views in the form of like events. Like it can send either using observables or using live data. Like basically my view is just receiving events from view model. Let's say anything. I just told you that live data is better because it's lifecycle aware, although it has like some small drawbacks. So between view and view model layer, it's perfectly fine. I think that's what we need. But then I also told you Room supports it, right? So Room actually can give me data in the form of live data. So like there's a third data. So basically Room will belong to somewhere in the model layer. So model layer can, so like say any update happens and Room just triggers like, okay, there's a new user got added, and my view model is gonna talk to model layer. So view model receives that event, and then it just makes that user, say it's an API user, it makes it to a UI user and gives it back. So this is possible, but where do we draw the line? When not to use the live data? So I think it's very simple. Live data has come into picture only because knows like life cycle. And so I think it is really complicated and inefficient, I would say, because you have to manually handle threads and all when you try to use live data in your second part, which is between model and view model. It is perfectly fine to use between view model and view, because your user is going to interact, your screens are going to change a lot, it can go in different states. But when it comes to view model, nothing is going to happen. Like your user is not going to interact with view model, it's going to interact with it's not going to interact with the view model, it's just going to interact with the view. So it is fine to use between view and view model. So how we have done is, we have used a combined approach where model gives data to view model in using observables, because that is where no UI interaction will happen, and view model gives data to view using live data. Okay, so that is the combined approach, and that comes very handy when you use RX, because RX, when you make API call, you just return some kind of data to view model, and so it's an observable. So all the iterations, the flat map, everything happens on a background thread, and then when I subscribe, the final results I put inside a live data, and live data is tied to my views. My view is waiting on this live data irrespective of what my API gives. So we have used a combined approach, which is working pretty well. Because there's a disadvantage. So you have a service. You have a service which is waiting on a token. Okay, and all you have to do is put that token inside some DB or something. Now, what happens if you tie? So this is view, like a model which is giving some data, and you have to put inside like some DB. So this is not like UI interaction. It just happened. So if you tie this to a life cycle, there's a strong possibility that, say, if you tie to an activity dies, and then the token is received, the token will never get uploaded. When it won't even go to DB, because your view died and you tied this operation to a view. So that is where it is not really nice to use live data. So I think this will be my conclusion here. If you have any questions, you can just shoot.
So you don't see any issues with this hybrid approach you mentioned, like from model to view model you are using observables, and then from view model to
No, because it's quite straightforward. I mean, I don't need to, because live data, like if you see the advantage, like life cycle awareness. Where is the life cycle when our DB is giving me something? Life cycle comes when I change something. Like I give an interface for someone to change those.
So like there are some traditional approaches like callbacks, event bus. Are you not using?
We are using. So so not for like everything. So some places when we want just some messages to be displayed or something, so we just pass using event bus. So then when there's like a lot of data, then we go ahead with the mutable live data approach, because messages can because event bus might not so event bus, once I publish them, when I rotate the screen, it might not appear, but if I want the data to stay there, then I have to go ahead with the live data. So basically live data is like a state which you save.
For Alex, right, like the learning curve is a bit high, that's what I think. How did your team capture on Alex?
I don't know, that's my favorite live data now. So yes, it is pretty big. It is very vague, but I think the concepts are very similar. Like the whole idea is publisher and subscriber. Okay, then there's subjects which can act as both. So that's it. Like, but it has like a lot of advantages, like multi-threading and all comes. It's just inbuilt there. Although I see some disadvantage now that Kotlin coroutines have come, which they say is like user level threads and not kernel. So here there are disadvantages, because all the RX call happen on like a kernel level thread, so which is like an overhead. But I don't know, it was easy. But we did take like 7-8 months to get hold of it. Although I think a flat map took the maximum time. I think it's fine. Thank you.
Thank you.